Hi everyone, so today we're going to be working on section 5.7, graphing a system of linear inequalities, and we are on page 309 in our binder. And just like the last video, you need to be doing this work in your binder. It cannot be on a separate sheet of paper. So in this section, we are going to not just be talking about one linear inequality, but now we're looking at two, which is a system of linear inequalities. So some of the steps are going to look familiar to what we did in 5.6, as well as just graphing a system of equations anyways. So looking at example 1, we have y is greater than 2x minus 5 and y is less than or equal to negative 3/4 x plus 3. So step 1, it says to convert to slope-intercept form or graph using x and y intercepts. In this case, we're already in slope-intercept form, so we're good to go. But if we do need to change anything, an important note is to remember to flip the inequality sign if multiplying or dividing by a negative number. So again, just like what we've dealt with inequalities in the past, if you are multiplying or dividing by a negative number, that sign flips. Okay, so let's start graphing these. I'm just gonna put some reminders on here. For y is greater than 2x minus 5, my slope is 2/1. My y-intercept is 0, negative 5. So in this case, we are using a dashed line because there is no equal to. Now our next equation, again, I'm just writing the slope and the y-intercept just as reminders. And then this one is an equal to, so it's going to be a solid line. So now, just like we did in 5.6, we're going to test a point for each inequality, and we're going to use 0, 0. Okay, so for the first one, we find when we plug in 0, 0, we find that 0 is greater than negative 5. This is true. So what I'm going to do here, since it's in that quadrant, what I'm going to want to do here is I'm going to not completely color it in. I'm just going to draw some perpendicular lines because I know it fits in there. Now our next point, we're going to do 0, 0 again, but with the other line. I get 0 is less than or equal to 3. This is also true. So since that is also true, I'm going to take my blue line and I'm going to shade it down. Now what you can see from here, based upon where I did my shading, there's a spot that overlaps. That overlapping part, that is my solution. So this whole area is what makes our equation true. So this is one method of figuring out what makes the equation true. In a minute, we're going to look at another method of being able to do this. Okay, so let's look at example 2, letter A. So again, both of these are already in slope-intercept, so I'm just going to graph each of them. So my first equation, just putting my dots in, and again, because there's no equal to, it's just going to be a dotted line. Okay. My next one, I'm going to do in blue. And again, just a dashed line. Okay, so this time we are going to try a different way. Instead of shading, I want to show you a different method. So we're going to still test it like we did before, but this time I'm going to label our 4 sections here, and you can see it based upon where the lines kind of break it up. So we have 1, 2, 3, and 4. So my test, 0, 0. So I'm going to first do the y is less than x plus 3. 0 is less than 3. That works. Okay, so if I know that works, so this means that 0 is less than 3, which is true. So that means this section here does not work, and this section here does not work. Because again, it's everything above that red line. Now, let's take a look at our blue line here. Again, using the test point 0, 0. 0 is less than 2. Okay, so that is also true. So that means anything above 0, 0, so above that line, does not work. Okay, looking at this then, if you notice, my 1 has been crossed out, my 2 has been crossed out, my 3 has been crossed out, my 4 has not been crossed out, which means that anything in this section is true. So this is just a different way, if the shading didn't work for you, to break it up into 4 different sections and test and then cross off versus trying to figure out where that shaded area is. So the last part of the question, it says list one solution to the system. So I'm going to choose just any point in the yellow section, and I like -1, -1. That would be right here. That solution makes both of those inequalities true. So again, we're going to graph another set of inequalities. I'm choosing colors again. That's helping me figure out which goes to what. But if we look at this first one, it's 4y is less than 8x minus 8. I first need to divide by 4 on both sides. So I get 2x minus 2. So I'm going to be able to graph that. Again, there's no equal to, so it's going to be a dashed line. Now our next one is y is less than or equal to x minus 1. And this one's going to be a solid line because it has the equals to. Okay, so now our next step is we are going to label our sections. And again, this is why this method might be easier for you to follow, because if you notice, some of our sections are very, very tiny. So again, we're going to test 0, 0. My first equation, y is less than 2x minus 2. 0 is less than -2. That is not true. So since that is not true, 0, 0 is not part of this answer. So that means we're crossing off 1 and 4. Now let's test out y is less than or equal to x minus 1. 0 is less than or equal to -1. Nope, again, that does not work. So I am going to cross off. I would cross off again 1, and this time 2. So anything that is above that line. So now if we're looking at it, 1 is completely out, 2 is out, 4 is out, which means 3 is our solution. And take a look at where I'm shading here. This one definitely isn't as easy to follow, so it's this is why testing the sections might make it a little easier. So anything in that yellow highlighted section, that would make the system of inequalities true. So this question at the bottom says, list an ordered pair that is a solution to only one of the inequalities. So when I'm looking at this, I know that it has to work for one of them. So if you notice in 2, in that little section 2, only one of it was only crossed out once, and that was by the second equation, but it would work for that first equation. So I'm just going to choose this little point up here, and that is 5, 5. And if you plugged it back into that first equation, it would make it true. All right, we're going to move on to our final example, letter C. We have x is greater than -3, and then we have 2/3 x minus y is less than or equal to 2. So first things first, I need to get my second equation in y equals mx plus b. So we would subtract 2/3 from both sides. And again, I'm not going to show that to you because this should be more of a review. And I get -2/3 x plus 2. Okay, right now we have -y, so I have to divide everything by -1. Now let's go back and think about that step 1. It said, remember to flip the inequality sign if multiplying or dividing by a negative number. In this case, I am. So now I flip the sign, so it's y is greater than or equal to 2/3 x minus 2. Okay, so we're going to go back up to that top equation that we need to graph, and that one this time is going to be blue. It's x is greater than -3. Ooh, think about this. This is just going to create a vertical line. So here's -3. And I'm making a dashed line because it's just a greater than. Okay, so I think with this problem, because we've done 2 examples with marking off 4 sections, this one I'm going to go back to the shading. So if I think about checking 0, 0 again, I get 0 is greater than -3. Well, that's true. So again, I'm just going to draw some perpendicular lines because I know anything to the right of this line would make that inequality true. Now let's draw our second line. Okay, and since this has an equal to, it's going to be a solid line. And now I need to do the test. So here we go, the test. 0 is greater than or equal to -2. Well, that's true. So if 0, 0 works, anything above that. So now, looking at where the areas are shaded, this section here, where you have both your blue and your red, that is the area that makes both inequalities true. That makes the system true. So now the final question is asking, is -3 -4 a solution to the system? So first, let's figure out where that is on our graph. So I just drew it here. So it's on the solid line, which is representing a equal to. So that would work. But then if you notice, my blue line is dashed. Points on the line are not a solution. So while it works for one of the lines, it does not work for both. So is this a solution to the system? No, it is not. So hopefully here, when you're just looking at the 2 different ways to find that area that makes both inequalities true, you can either choose to do the shading or looking at it in 4 sections. So if you have any questions, just let us know.